In this lesson, as I say, I want to start with this idea of why do we need to change, why now? I think you'll understand that any industry in modern times has to be constantly improving. And these code changes really help us, provide us with an opportunity to provide our customers, our homeowners, with ever better, healthier, safer, more durable, more efficient housing. And in each code iteration, we're going to see over the next 5, 10, 15 years, a really responsible movement towards ever better performing houses. So it's good for an industry to be on this path of continued improvement. Second, the code changes very nicely in this iteration have really taken a nice, proper, appropriate, scientific approach to the code changes, understanding the effects, and we're going to talk about it, air, heat, and moisture flow. And you'll find some really nice changes within the code that are very respectful of what we've been finding in building science as being really important key determining factors for the durability, health, safety, and efficiency of houses. Third reason is you're going to find by the end of the 4 lessons that it really improves the affordability of houses. In today's world, there's really no better investment than energy efficiency. With the price of energy as high as it is and the cost of borrowing as low as it is, and given these economic times, anything that improves the affordability of houses, I think you would agree, would be very positive. And I will be able to show that the code changes are very respectful and in fact are very, very cost effective, both for builders and for home buyers. Lastly, I think I'll also be able to help you with an understanding of how the code changes in building science link together to minimize risks for builders, to really find ways of building houses that have fewer problems, that meet the expectations of today's ever more demanding consumers, but also avoid some of the pitfalls of moisture, comfort issues, durability issues. So those are really good, 4 good, compelling reasons why these changes are very important right now. And when we think about those changes, I always like to put them in perspective that sometimes we worry that code changes are going too far too fast. And I just want to remind you of some of the key changes that have taken place over the last 15, 20 years that really impacts the way our houses work anyway. Let's start with enclosures. And enclosures have changed dramatically. We're building bigger houses. We're building more complicated houses. We're also putting more mechanical systems into those houses. We're going to touch on that. And then lastly, we're going to talk about the lifestyles and the expectations of consumers. With respect to enclosures, I think we can all recognize that the bigger, taller, more complicated houses with bigger windows, deeper basements, different building materials, more insulation, greater levels of air tightness, greater levels of expectations with respect to design can put huge stresses on the way houses work. Let's use a couple of quick examples. Let's start with windows. We all know that consumers love more and bigger windows. Windows are a great aesthetic feature of houses. Windows, of course, have some important energy considerations. More windows on the south side in the wintertime can be quite lovely, adding lots of heat and warmth during the day. But windows on the west side, or even on the south side for that matter, but on the west side specifically, in the summertime, can really cause a lot of overheating issues, comfort issues, in a society now that spends more time indoors. So windows have kind of a double-edged sword. We love the look. We worry about the energy impact, both summer and winter, of those windows. And windows are just one example. Let's talk about foundations. 30, 40, 50 years ago, we dug foundations really for frost protection. We never expected them as living space. We maybe stored some pickles or did laundry down there or shot hockey pucks as young kids, but now we're using those basements for far more. They've become important parts of the overall usable space of a building, and we're finding kids sleeping in basements, we're finding family rooms down in basements, big screen TVs. It's really become a very valuable spot, and the moisture issues related to basements make them very difficult to accomplish. Imagine living in holes in the ground. It's not a very simple thing to do. So as we make those changes in the expectations of the way buildings work, we really need to change the way we build houses to take advantage of those expectations. Second, on the mechanical side, I think we'll all recognize we've added far more things to our house than ever before. More plumbing, more appliances, more lighting. All of those are new sources of heat and moisture within our houses. All of those, frankly, can be sources of pollutants as well. So mechanical system changes have had a huge impact. And probably the most important is air conditioning. Very small percentage of houses 30, 40 years ago were air conditioned. And now we're finding a significant number, 75, 80, maybe 90% of houses air conditioned. And you say to yourself, why might that be? Is it because the environment has changed? Well, one of the key determining factors of air conditioning is in fact windows. Windows account for up to 50% of the need for air conditioning. If you have a 4-ton air conditioner, it's because you have 2 tons worth of heat gain through the glass that you're now installing. So homeowners want bigger and better windows, but that leads to a need for more air conditioning. That completely changes, as we'll see in further lessons, that completely changes the dynamics of air, heat, and moisture flow across building envelopes from season to season. Very, very important change. It also means that because we have more and bigger windows, more air conditioning, people actually open windows less. It used to be that we could rely on people opening windows throughout the spring, summer, and fall. And now, because of air conditioning, people leave those windows closed, which presents a need for mechanical ventilation. A whole new series, a whole new generation of products that are now coming into houses. Bathroom fans, ventilation systems, dryers, rain sheds, all competing for air within our buildings. And last and probably most important of the changes is in our home buyers, their expectations of the way houses work. One, we're spending far more time indoors than ever before, up to 90% of our time indoors. And because of that, our expectations of comfort have changed. What used to be normal comfort levels might have been 5, 10 degrees Fahrenheit variation between rooms and spaces. Because you weren't in houses all that often, didn't stay in them all day, those changes in temperatures really didn't bother us. But now if you're inside 90% of the time, even small fluctuations in temperatures really don't meet the expectations of today's consumers. Because we're spending more time indoors, bring more things indoors with us. Plants, pets are now all fixtures within our houses. They have impact with respect to air quality, as do all the stuff that we have, all of the fabrics and furnishings and clothing and personal hygiene products. These all have huge impact on the air quality within our buildings. And the expectations of consumers with respect to health, comfort, durability, the fact that we want things to be maintenance-free and we don't have the time to do proper maintenance. All of these put huge stresses on our buildings. So when you think about the enclosure changes, bigger, more complicated houses, when you think about mechanical changes, we think about air conditioning, more ventilation, more appliances, more plumbing, and we think about the lifestyle changes. This all has huge impact on the way houses work. And what we've referred to as the house as a system. Every change impacts everything else. So the example we used was windows. More and bigger windows needs more air conditioning, which means we open windows less, which means we need mechanical ventilation in houses. And you're starting to see codes respond to that. Our expectations for greater comfort mean we need more insulation. The expectations to use basements differently, then we need better moisture management in those basements. So every change impacts everything else. And this is why we try to introduce the idea of building science. Because building science is a scientific approach to these changes, understanding the physics behind the air, heat, and moisture flow of buildings that allows us to avoid risks that might be inherent, say, in finishing a basement, but also finding new opportunities, better ways of using building materials and thermal performance to downsize mechanical equipment and so on. So again, that example of the bigger windows, more air conditioning, better sizing of that air conditioning system, understanding the thermal gain and thermal losses of those windows, and using and then providing for mechanical ventilation within houses. That house as a system is vital to this overall conversation. So what exactly is this building science that I've been mentioning? Building science is really fundamentally the flow of three things: the flow of heat, the flow of air, the flow of moisture. The basic building blocks of the physics behind the way houses work. And how does that impact code, you might say? Well, the code very clearly, the Energy Conservation Construction Code, very clearly is starting to think about managing heat and airflow in a different way, a more cost-effective way, a more affordable way, and with respecting the rules of moisture to ensure that we're not affecting the durability of houses, because moisture is the number one thing that will destroy buildings. So the latest Energy Conservation Construction Code of New York State helps with defining better the elements of heat flow, most specifically airflow. We're going to talk about that in future lessons, and the impact on moisture flow. And if we started with the conversation of heat flow, what we really need to do is understand the science of that. Where exactly is the energy going in our buildings? And lots of studies have been done in many places, but in this climate zone, fully half, almost half, of the total energy use of a single-family house is in space heating needs. In this slide, 47%, but it will vary by location, it'll vary by household, but in essence, in the standard single-family dwelling, we can expect that half of the energy use in a building is associated with the space heating needs. Another 20-25% associated with lighting, water heating at 15 to 20%. You notice that air conditioning is really a very small segment in this climate zone. This provides us with great opportunities for savings. Once we've understood that it's really about space heating, you'll notice in future lessons we'll really work on and highlight the needs for managing heat flow in and out of buildings in the wintertime, still respecting the basics of durability and affordability, but managing that heat flow. Of course, there are code elements and code segments with respect to lighting and appliances, but that will come later. In the next lesson, we'll focus on heat flow and airflow and the impact that it has on code changes.